Hello, fifth graders, and happy Friday. Today we're going to talk about the relative size of the product and the factors of a multiplication problem. We're going to see what kind of numbers you can multiply by to create a smaller, bigger, or equal product. Let's dive right into our lesson. I know you can do it, and so does Mr. Smiles. Let's start by going over our do now. Alencia had 4 cakes. She let 3 friends share the cake evenly. How many cakes did each friend receive? First, what operation is being used to solve this problem? Division is being used to solve this problem. Alencia is splitting up the 4 cakes. What's being divided in this problem? 4 cakes are being divided. So what's our division problem? It's 4 divided by 3. How do I write 4 divided by 3 as an improper fraction? 4 divided by 3 is the same as 4/3. Dividend over divisor. That's not quite a final answer. How can I change 4/3 into a mixed number? I can divide 4 divided by 3. How many times does 3 go into 4? 3 goes into 4 one time. What's 1 times 3? It's 3. When I subtract, how many do I have left over? 1. So my answer is 1 and 1/3. Now let's do a multiplication problem. What's 3 and 52/100ths times 3 and 5/10ths? Remember, when I multiply with decimals, I don't have to line them up. First, how many digits are going to be behind the decimal point in my product? Well, there's 1, 2, 3 digits. Now I can multiply like normal. What's 5 times 2? It's 10. What's 5 times 5? It's 25. Plus 1 more is 26. What's 5 times 3? It's 15. Plus 2 more is 17. Now I'm finished with the 5, and I need to multiply by the 3. Before I do that, what should I do? I should drop a 0 because the 3 is in the tens place. Now I can multiply. What's 3 times 2? It's 6. What's 3 times 5? It's 15. What's 3 times 3? It's 9. Plus 1 more is 10. Now I can add my partial products. When I do that, I get 0, 12, 13, 2, and 1. Now, where should I place the decimal? Which answer is correct? The decimal should have 3 digits behind it so that I end in the thousandths place. Hundredths times tenths is thousandths. So the correct answer is 12 and 320 thousandths, or 12 and 32 hundredths. Let's look at another question. Tyler was doing an art project. He had 4 pounds of clay. He tore off pieces that each weighed 1/3 of a pound. How many pieces could he tear? What operation do I need to use to solve this problem? This is a division problem. Tyler is splitting the clay into equal pieces. What division sentence could I use to solve this problem? I could use 4 divided by 1/3 because 4 pounds of clay are being split up into 1/3 pound pieces. I know that I can draw a model to solve this problem. Go ahead and draw a model, then enter your answer in the box. What's 4 divided by 1/3? There are 12 1/3s inside of 4, so the correct answer is 12. Tyler could tear off 12 pieces. Let's look at number 4. Mr. Brown had 1/5 pound of rice to cook for dinner. He let 4 people share the rice evenly. How many pounds of rice did each person receive? What operation do I need to use to solve this problem? I need to divide. Mr. Brown is splitting the rice evenly between 4 people. What division sentence should I use to solve this problem? I should use 1/5 divided by 4 because 1/5 pounds of rice is being split up. Go ahead and draw a model to solve 1/5 divided by 4. How many pounds of rice did each person receive? Solve that problem now. The correct answer is 1/20. Each person received 1/20th pound of rice. Let's look at number 5. What's 3 1600ths divided by 4? Well, let's start by writing 3 1600ths inside of our division sign and 4 outside. I know that I need to bring the decimal point straight up. Now let's see. Can 4 go into 3? No. It goes into 3 0 times. I need to place a 0 in the ones place and start my division with 31/10. How many times does 4 go into 31? 4 goes into 31 7 times. What's 7 times 4? It's 28. I can subtract. What's 31 minus 28? 31 minus 28 is 3, and bring down the 6. Now I can divide again. How many times does 4 go into 36? 4 goes into 36 9 times. What's 9 times 4? 9 times 4 is 36. When I subtract, there's none left over, so the answer is 79/100ths. Let's look at number 6. Michaela completed 2/3 hours of homework each night for 4 nights. How many hours did she work on homework? What operation would I need to use to solve this problem? I would need to multiply because I'm repeatedly adding 2/3 hours of homework. What's 2/3 times 4 written as an improper fraction? It's 8/3. Now I can change it into a mixed number. When I change 8/3 into a mixed number, what's the result? 8/3 written as a mixed number is 2 2/3. Now let's do some fluency problems. Go ahead and solve the first column. 28 divided by 4, 14 divided by 7, 10 divided by 5, 35 divided by 5, and 15 divided by 3. Solve those problems now. Check your work with mine. Now solve the second column. Check your work with mine. Now solve the third column. Check your work with mine. Now solve the fourth column. Check your work with mine. Now let's dive into today's lesson. We're going to look at what happens when I multiply by a fraction less than 1, by a fraction equal to 1, and by a fraction greater than 1. Let's start by looking at multiplying by fractions less than 1. 8 times 1/2. What's 8 times 1/2 written as an improper fraction? It's 8/2. I can divide to change that into a whole number. What whole number results when I divide 8 by 2? It's 4. 4 times 2 is 8. So 1/2 times 8 is 4. Now I want you to think, is 4 less than, greater than, or equal to 8? 4 is less than 8. Let's multiply by another fraction. What's 8 times 3/4? Well, how do I write 8 times 3/4 as an improper fraction? 8 times 3 is 24, and my denominator stays 4, so I have 24 over 4. Now I can divide to change that into a whole number, 24 divided by 4. What's 24 divided by 4? It's 6. Now let's think about how our product changed. Is 6 less than, greater than, or equal to my original 8? It's less than. Now let's do one more. 8 times 5/8. What improper fraction results when I multiply 8 times 5/8? 8 times 5 is 40 over 8. Now I can divide to change that into a whole number. What's 40 divided by 8? 40 divided by 8 is 5. So the product is 5. 8 times 5/8 is 5. How does that compare with my original factor? Is 5 less than, greater than, or equal to 8? It's less than. So what I saw in all three examples is that when I multiply by a fraction less than one whole, the product is less than the original number. I actually create a product that is smaller than my original factor when I multiply by a fraction. What happens when I multiply by an improper fraction or mixed number? Let's try it. 8 times 3 halves. How do I write 8 times 3 halves as an improper fraction? Well, 8 times 3 is 24, and the denominator stays 2. I can divide to change that into a whole number. What's 24 divided by 2? It's 12. 24 divided by 2 is 12. So 8 times 3 halves is 12. Remember, 3 halves is greater than 1. It's an improper fraction. So is 12 less than, greater than, or equal to 8? 12 is greater than 8. I multiplied by a number greater than 1 and created a greater product. Let's do another one. 8 times 1 1/4. Remember, to multiply 1 1/4, first I have to change it into an improper fraction. What's 1 times 4? 1 times 4 is 4, plus 1 more is 5, and the denominator stays 4. How would I write 8 times 5/4 as an improper fraction? Well, 8 times 5 is 40, and the denominator stays 4. I can divide to change that into a whole number. What's 40 divided by 4? I just gave you the answer. 40 divided by 4 is 10. Is 10 less than, greater than, or equal to 8? 10 is greater than 8. So, when I multiply 8 times 1 1/4, I get a greater answer. Now let's do another. What's 8 times 2? 8 times 2 is 16. Is 16 less than, greater than, or equal to 8? 16 is greater than 8. So, what I learned here is when I multiply by a whole number, mixed number, or improper fraction greater than 1, the product is greater than the original number. What happens when I multiply by a fraction equal to 1? Remember, fractions that have the same numerator and denominator are equal to 1. So let's try a few. What's 8 times 2 over 2? Well, how would I write 8 times 2 over 2 as an improper fraction? I would write it as 16 over 2. When I divide 16 divided by 2, what's the result? It's 8. Is 8 less than, greater than, or equal to 8? 8 is equal to 8. Let's do another. What's 8 times 4 over 4? Well, how would I write 8 times 4/4 as an improper fraction? I'd write it as 32 over 4. I can divide to change that to a whole number. What's 32 divided by 4? It's 8. 8 times 4 is 32. So the result is just 8. Is 8 less than, greater than, or equal to 8? It's equal to. Now let's try one last one. How would I write 8 times 8/8 as an improper fraction? Well, I'd get 64 over 8. I can divide to change that into a whole number. What's 64 divided by 8? 64 divided by 8 is 8. Is 8 less than, greater than, or equal to 8? It's equal to. So what I learned here is that when I multiply by a fraction equal to 1 with the same numerator and denominator, the product is equal to the original number. We're going to have some practice now. To determine the relative size of the product, first, determine if the second factor is less than 1, it's a fraction, greater than 1, it's a whole number, mixed number, or improper fraction, or equal to 1. It has the same numerator and denominator. If it's less than 1, if it's a proper fraction, then the product is less. If it's greater than 1, if it's an improper fraction, whole number, or mixed number, then the product is greater. And if it is equal to 1, the product is equal to the original number. Let's do some practice. Tell whether each product would be greater than 4, less than 4, or equal to 4. 4 times 5 halves. Is 5 halves less than 1, greater than 1, or equal to 1? 5 halves is greater than 1. So this will be greater than 4. 4 times 5 fifths. Is 5 fifths greater than 1, less than 1, or equal to 1? 5 fifths is equal to 1, so this will be equal to 4. 4 times 5 eighths. Is 5 eighths less than 1, greater than 1, or equal to 1? 5 eighths is less than 1, it's a proper fraction. So this answer will be less than 4. Now you try a few. Would 4 times 2/3 be greater than 4, less than 4, or equal to 4? 2/3 is less than 1, so this answer would be less than 4. 4 times 2 and 5/6. Would that be less than 4, greater than 4, or equal to 4? 2 and 5/6 is greater than 1, so this would be greater than 4. 4 times 9/9. Would that be less than 4, greater than 4, or equal to 4? 9/9 is equal to 1, so this answer would be equal to 4. Now you try a stop and jot. Alex says that multiplication always makes a bigger number. Why is he incorrect? Go ahead and answer that question now. Alex is incorrect because when you multiply by a fraction less than 1, you create a smaller product. When you multiply by a fraction equal to 1, you create an equal product. You only create a larger product when you multiply by a number greater than 1. Let's look at numbers 1, 2, and 3. Number 1, select all the numbers that Logan could multiply by 54,216 to get a product less than 54,216. So find all of the fractions that are less than 1. Which answer choices are correct? A and D are correct. Both of those fractions are worth less than 1. Select all the numbers that Logan could multiply by 54,216 to get a product greater than 54,216. So find all of the numbers that are greater than 1. The correct answers are C, E, and F. Mixed numbers, whole numbers, and improper fractions are all greater than 1. Now look at number 3. Select all the numbers that Logan could multiply by 54,216 to get a product equal to 54,216. Which fractions are equal to 1? The correct answer is B, 4 over 4. It has the same numerator and denominator. Now you try 3 on your own. Which product will be less than 3? The correct answer is C, because 3/5 is less than 1. Which product will be greater than 3? The correct answer is A, because 5/3 is greater than 1. Which product will be equal to 3? The correct answer is B, because 3/3 is equal to 1. You've done a great job on this video. Now it's time to move on to IXL Practice M.17, scaling whole numbers by fractions. Try to get to 90 as your SMART score. I know you can do it.